Hello everyone, this is Qiang Wang from Alibaba. Today I want to introduce our recent project RCL Recurrent Continuous Localization for Temporal Action Detection. The evolution of temporal action detection has a long history, and the topic became popular with the growth of temporal content. We think the kernel of this problem is the formulation of temporal segments, which means how we use deep model to represent a temporal segment. And at the beginning, the researchers use actionless score and post-processing methods to detect a star and endpoint. And then researchers introduce anchor-based detection from image detection to 1D temporal action detection. For example, we can use multi-scale anchors or anchor-free methods to regress the temporal segments. And the state-of-the-art methods use a novel 2D representation methods to transform the location of star point and endpoint into a 2D heat map. And the point of the local minimal is the temporal segment we want. However, we found the representation accuracy is related to the number of the feature samples. For example, by representation, a 1 minute video with 20 features, and the highest representation accuracy is 3 seconds. In addition, due to the discretive representation, several simple imbalances causes and the most simple service for long-term segments, the result in a large number of missing detection for short-term segments. In order to solve the above problem, our method is a significant step forward. We introduce a continuous representation, specifically the purpose representation built upon a model conditional with video embedding and the star and endpoint, which ensures the capability of detection segments with attribute lenses. Compared with other frameworks, our method simply adds 2 additional channels of the input. However, to optimize the continuous representation, we developed an efficient scale-invariant simple strangeness and recurrent refined modules. And the simple strangeness consists of 3 parts. The first part is regular grid simples as previous methods, which can serve as a stable baseline for our algorithm. And the second part is random simple in continuous representation space by moving a point randomly. And the third part is our scale invariance sampling, which can help increase the robustness of the short-term segments. This work only learns a few layers and a few steps, mainly because the module requires additional polling operation. While in our continuous representation framework, we propose to use the recurrent refined module to continuously optimize our distribution. Each simple point is adjusted by the prediction offset and re-input the network, our loss function, and our experiments mainly on Thomas and activity night. Compared with the current state-of-the-art methods, our MAP improved by more than 2%. And in the evaluation study, our accuracy and efficiency are improved compared to the methods directly increases the input resolution, and which demonstrates the efficiency of our continuous representation. Both our scale invariant simply and recurrent refined methods improve significantly. To further demonstrate our math experiments, we conduct a detailed error analysis and found our algorithm mainly improves the recall of short duration segments. Thank you.